Yes, and thanks to Dr. Alvaro Asornio Vargas at the University of Alberta, I've had many opportunities to bring the geographic perspective to children's health research. And I hope to share my passion for GIS-based research with you all in today's webinar. And through a mix of slides and a short demo, we will cover the following. So I'm going to go over what is GIS, setting the stage with base maps and map projections, geolocation, or how do we get those medical records onto a map, and some selected spatial methods to aggregate data into administrative units or determine what is nearby, and where to learn more. But before we go into details on what GIS is, first we will start with what GIS is not. And when talking with many different researchers, I find out we have a lot of misconceptions. And first of all, GIS is not the same thing as GPS that you have in your car or on your phone. GPS stands for Global Positioning System. The data from it can be used in GIS analysis. GIS is not a static map. The digital or paper map is an input or a product of GIS. It's a way to visualize. And it's not just the software. Software are the functions and tools needed to store, analyze, and display geographic information, but it requires hardware, data, personnel in a complete system. And GIS is not just a database. IT people might say, oh, yes, it's just a spatial database, but it's a database is a set of tables containing data that can be accessed or reassembled in many different ways, but it requires a link to the spatial data. So GIS is the acronym for Geographical Information Systems, and we can thank Canadian for actually coining that term way back in the 60s, working on soil data. And so it is the combination of skilled people with analytic methods, spatial and descriptive data, as well as software and computer hardware, all organized to automate, manage, and deliver information through geographic presentation. So GIS is a method to visualize, analyze, display spatial data, and it's the process of combining layers of information about a place that gives us a better understanding of that place. So we talk a lot about layers of information when you have a GIS, and these are essentially the maps, but these maps are linked with databases. So GIS is essentially a database that understands geometry, and its links between the features, and we have a graphic here showing dissemination areas from census geography, and these features are shapes that have attributes or values in an associated table that make it possible to ask questions about the information stored in the attribute table and display the answer on a map. And this makes GIS much more informative than static maps. And the map layers are represented in spatial data models. And tables of data can be linked together and joined to different types of spatial data, such as vector and raster data. Vector data models discrete features as points or coordinates, and lines or arcs. And then when you have lines enclosing areas, we have polygons. And these have precise boundaries and shapes with attributes. So you may have heard of file types such as feature class, shapefiles, or CAD drawings. And raster data models continuous phenomena in a surface divided into a regular grid of cells or pixels, just like our digital photos from our cameras. Each have an associated attribute value in those pixels or cells. And example file types are grid coverages, tagged image file format, or digital photos. And most GIS software works with both vector and raster data, and today we will focus on vector only. And as indicated in this webinar's abstract, we will use the ArcGIS platform to prepare, visualize, and analyze some simulated locational data, specifically from the Cancer in Young People in Canada data. And ArcGIS Desktop is the global industry standard for mapping, analyzing, and managing spatial data. And this is what the ArcMap application looks like for anybody who hasn't opened it up before. As with any other Windows program, there's a main menu along the top here and standard toolbars. And this gives us access to opening and saving files, editing, copy, paste, things like that. Help, very important as well. And there are two main panes in the window that are important. There's a table of contents, and then there's the data view. This is where we can visualize our map layers. And all the items we work with are indicated in this table of contents. So it lists the items in the map, and they're organized into containers called data frames. And we have the list of the map layers, and you can change the drawing order. You can check them on and off to control how you want to view and visualize. And so we start our project with a base map to provide a background of geographical context for the content we want to display in our map. So we're not going to just simply start adding our medical data. We need to have background information. And so when we create a new map, we can go to the Add Data button in the ArcMap interface and choose which base map we want to add. And there's a gallery of them. And then once you select it, then you can click Add. And you can change this background map if you want to try out a different one. And this example here shows a comprehensive street map for the world that includes highways, major roads, minor roads, railways, water features, administrative boundaries, cities, parks, landmarks, overlaid on shaded relief imagery for added context. That's a lot of information. And if you didn't want the space map, you would then have to download or access all these different layers and manage the data locally, which takes quite a bit of time. We can use zoom in, zoom out tools and a pan tool to move throughout the map, or even the roller controller and the mouse, and you can navigate to the location of the world. So we can zoom in, for example, into Alberta, the area that we're going to focus on for today. We can also add our own data layers, and here we can add an outline of the province of Alberta. So you navigate to your directory that holds all your data. You may have to click on this Connect to Folder button when you first have the software installed on your computer. It needs to know where to look. Select the file you'd like and click Add, and then you can quickly edit the symbol so that we can see the base map below. So rather than just having a colored rectangle, if you click on the symbol patch, which is the colored rectangle underneath the name of the layer in the table of contents, we quickly get a symbol selector. We can select a hollow, so no fill color, black outline, and give it a thicker width. And I'll show you what that looks like in just a moment. And I'm going to go through these slides fairly quickly, but you'll get a feel, if you've never used the software before, of where to point and click to go through these different tools and commands. And then when I do the demo, it won't be such a blur for you. So now you can right-click on the Alberta layer, and you can zoom to the layer, and it will then set the focus of your map at the optimal zoom of the layer. And then the next step, we're just going to save our map document before proceeding. But I always advise before you do that to set the map document properties, and then you check this box, store relative path names to data sources in the properties. And this will avoid broken data links when we move the files to another computer if we need to do that. And finally, we can hit the Save button, navigate to our working directory, and type a file name and click Save. And so then the next step that we want to do in our project is to set our desired map projection. It's always a good idea to do this at the start of your project, determine what you need to preserve, how you need to display the data. And I don't recommend sticking with a geographic map projection. You often see these in publications and other presentations where the world looks all stretched out east to west and squashed north to south. Map projections will give you a coordinate system for your spatial data, provide a common basis for communication about that place or area on the Earth's surface. And when you choose a projected coordinate system, we then have constant lengths, angles, and areas across the two XY dimensions. And the world, or the area of the world that you're portraying on your map, will look more reasonable and what you would expect for the shape, as well as preserving different properties of the map. And if you're interested in learning more about map projections, there's a link at the bottom of the slide that gives you a lot of detail. So the choice of map projection depends on the part of the world we are in and what property we wish to preserve, so shape, area, distance, or direction. And we're working with Alberta data today, and the provincial standard is actually a 10 TM, a transverse Mercator type projection. However, our future analyses requires distance calculations, so we want to preserve the distance function or property. And so we have a custom Alberta azimuthal equidistant projection. And so to change the map projection, you simply go to the data frame properties, and then we can click on the coordinate system tab of those properties, and we can choose the projection we want. As I mentioned, there's geographic and there's projected, and we're going to import the projection from the Alberta layer that I added, which is the custom Alberta azimuthal equidistant. Otherwise, you'd have to find a similar projected coordinate system and then modify it, and we don't have time to go through that today. And then we can right-click on it and zoom into it again, and so this is what it looks like after we've projected, and this is what it looked like before. And so the base map is based on a Web Mercator projection that is used in Google Maps, Bing Maps, all the online maps that you see, and it gives you that kind of squashed and straight line with your longitude and latitude, whereas with our projected data, it looks more reasonable. We see curvature of the Earth and the large boundaries of our province. So we've set our projection. Now we're ready to add our point locations. And this is through the process of geolocation. So as discussed in the first two webinars of this series, the CYP-C data have the full 6-digit postal code, although I understand just 3 digits for BC. And so it allows for geospatial analysis at this resolution. And because we have the postal codes, we use geolocation to then visualize these records and their attributes on a map. And as the GIS dictionary, I have the link there, as it defines, geolocation is the process we use to translate a table of XY coordinates to point features. So because we have the postal code, we can then access the longitude and latitude and then get those points on a map. And due to confidentiality, we're going to use simulated data today with very basic attributes. So we have children less than 15 years at diagnosis of cancer for the province of Alberta for a subset of postal codes. So geolocation is a process outlined here, and first thing we need to do is clean, then add, join, export, display, and then export again. And so I'm going to go through each of these steps in the next few slides. So when you clean and format your table, all the data cleaning discussion from the previous webinar by Giancarlo applies here. You need to standardize your attributes. As he says, no database is initially ever clean, and getting your data ready, even for spatial analysis, will take upwards of 80% of your time. And so we can have our table of the full 6-character postal code. However, due to data entry errors or even if patients are forgetful and don't have quite the exact postal code, we need to standardize them somehow. So capitalization matters, just like we were told in the last seminar. So T6G1 lowercase c9 does not equal all uppercase letters. And you also need to ensure that all are in the format of a letter, number, letter, number, letter, number. And so even though we might say TOLOCO as a postal code, they need to be entered as zeros. So the letter O is not the same as the letter 0 in this postal code. And often you might need to remove spaces. And you can either match or link postal codes with spaces, but sometimes there's no spaces in the table that you might be referencing. And so you can remove those spaces using functions in your software, but also make sure you remove any trailing spaces, because a space at the end of this postal code does not match one that doesn't have any space. So once you get your attributes standardized, and we also saw information in the previous webinar about how to do that with actual data. I'm just focusing on the georeferencing or the geolocation data here. You need to format the tables. And so if you're exporting from a Microsoft Access database or statistical software, you probably already have a lot of this information or this formatting done. Column headings must be present. So that seems pretty intuitive, but just make sure. And no non-alphanumeric characters can be in the headings when you're going to bring the table into the GIS software. So for example, don't have a % symbol or any other kind of fancy symbol that's not a letter or a number. And often you can't start with a number for the heading name as well. And do not use spaces. Also check at the end of the word. So if the column heading is a space at the end, it's going to show up as no data or nothing in the GIS software. Make sure you don't have any skipped rows in the table. And also keep in mind that date time values are subject to import errors. So you may have to split the date parts into separate columns of year, month, and day if this tends to be a problem for the type of format that your table is in. Then when you export the table from your statistical software, you can choose a DBase file, a comma-separated values file, or an older version of Excel. ArcGIS can only read Excel version 2003 or earlier, so if you have a .xlsx as your Excel extension, make sure to down save it to a .xls, and you'll be able to use it in the GIS. So once you've cleaned and formatted the table, you can add it into ArcGIS. And as I mentioned, an Excel file can be directly brought in. You use that Add Data button. You navigate to inside the Excel file, and you can see the different worksheets that are there. And then you can select them, and then you can add them. And then once you've brought it into the GIS, you simply right-click on the name of the table in the table of contents here, and right-click and open, and then you'll be able to view it. And if you see a bunch of blank values in your table, it means there's probably a space somewhere that you need to go back and fix. And then we need to join our tables together and get that postal code, longitude, latitude information in here. So just a little note, if you want to see standalone tables in ArcGIS, there is a way to list by source, and then you'll be able to see the tables. And then you right-click on the table name, and we're going to do what's called a join. And we're going to match the Diagnosis 1 group with the Diagnosis 1 group table, which has more descriptive information using the same field name. Keep in mind that the column headings or field names could be different in the two different tables. As long as they have the exact same values, then the join will work. And we'll do a second join of that original data table that will take the postal code for each record, match it to our postal code feature class or shapefile of points using that postal code field, and then we get a table that looks like this. And so we start out with our CYP-C ID, we have date of birth, gender, postal code, and there's a whole bunch of other information, but we have a very simple table for today's purpose. The diagnosis group, the postal code, and then here's the longitude and latitude, as well as dissemination and other census geography information could be in that postal code file as well. And so once we have our tables joined, we need to make this join permanent, and so we export this to a new standalone table just by right-clicking on the table, choosing export, and all the records will then get saved into a new file name. And for standalone files, you can use a dbase.dbf or a text file. And since we want to keep all the database definitions, I've chosen a dbase here. If you're more familiar with GIS software, you might want to put it into what's called a file geodatabase, and then you have a geodatabase table that's more specific to the software. And finally, we can display this data. So even though I'm going through this fairly slowly, this process takes a minute. It's really quick. So in the table of contents, we then right-click on this new table and choose Display XY Data. And then filling in this wizard is pretty easy, but you have to take care that you choose the appropriate X and Y field. If it's longitude and latitude, it automatically finds it for you. It knows how to spell those. And then you need to set the correct coordinate system of the input coordinates. So you may want your data to project to another map projection. You can't set it here. You have to tell the GIS software what the coordinate system of the inputs are. So when you have longitude and latitude, it's going to be geographic. It's not projected. And for our data, it uses North American Datum 1983. And then we can click OK. And ArcMap will automatically reproject the data to overlay with whatever map projection you have set in the data frame. And this gives you what's called an event layer. So XY events are not true spatial data files. And so there's a limitation to some of the tools and commands you can use on them. So to make this a true spatial data file, we're going to export the data. Just right-click on the events layer name, choose Data Export Data, and we can type an output file name, and we're using the shapefile format here. And if you click the option to use the same coordinate system as the data frame, it's going to permanently reproject from geographic longitude, latitude to whatever map projection system you've set in the data frame previously, which for us is the custom azimuthal equidistant. So we've done 2 steps in one here. Okay, so let's go on to some sample analyses with the data. So we can also explore the relationship of the CYP-C locations with other geographic features through some fundamental GIS analyses to answer how much, what's inside, and what's nearby. So it's a good way for us to start exploring our data and understanding a lot more about what may be going on in the environment surrounding these locations. So the first thing we have are summary statistics, and here we can summarize the table, and you can also do this in your statistical software. So this particular part isn't spatial, but displaying it afterwards will be. And this is just to aggregate the data by postal code and find out how many records we have for each location. And so if you right-click on your point file, open the attribute table, then when you're inside the attribute table, you can right-click on a column heading. Here we're going to use the field, attribute field postal code. You can choose Summarize, and so it's going to give us a summary table grouped by the values in this field. And then in this dialog, we could choose many different statistics for actual data. We're not going to do that here for the sake of time, but basically just to show you how this works. The tool automatically will give you a count or frequency, it's called count of postal code. But in order to save us time and having to join back the postal code to get the longitude and latitude, I'm going to just do a quick check of the box for minimum and minimum of longitude and latitude, because the longitude and latitude should be the exact same for every instance of the postal code record in the table. The statistic is basically just going to give me the actual value. And then you click OK, and you get this output table that shows you each unique postal code. So in the beginning, we had 333 actual records in our simulated data here. And now we have 200 unique postal codes. And the count of postal code tells us how many records we have in the table or the database. And then we have the longitude and latitude. So now it's just a matter of displaying the XY data. So you right-click on that summarized table, specify your X and Y fields, and again edit the coordinate system of the input so that you're using the geographic, because longitude and latitude are a geographic coordinate system. And then we can right-click on the events layer, or double-click, and get to the layer properties. And inside the layer properties, there's a symbology tab of where we can change how we represent the points. And so a simple way to look at counts is to use graduated symbols. So the larger the symbol size, it indicates a higher number or frequency. And we set the value field to the count of postal codes, and you can change the classification method however you want just by clicking this classify button. The default is natural breaks. You can change your number of classes depending on the range of values in your data. You can also click this template button to change the color and the symbol shape and things like that. And then once you've clicked OK, you will then see your records on the map showing where you have relatively higher and lower counts. So this is a good way to start understanding where we have the geographic variation in the CYP-C data. Okay, so the next simple analysis that we're going to look at is called an overlay, and specifically this one is a point in polygon. So here we want to count up how many records we have in a polygon. Now, if you're going to be working with census data, and Jason's going to be talking about this in a future webinar, there are files that help you link your postal codes with the census geography. If you don't have census geography, then like say health regions or other administrative boundaries that don't have a linkage file, then you need to do this kind of point and polygon overlay. And to do this, it's a join. Just like we did when we joined the two tables together to get the postal code information into the data file, the access is by right-clicking on your file. In this case, we've added dissemination areas as a polygon file. You right-click at the Joins and Relates join, and then the very top part of the interface, you change it to do a spatial join. So rather than joining by attributes, we're going to join data from another location based on spatial location. And we're going to choose the location's point file to join the data, and use the first option of each polygon will be given a summary of the numeric attributes of the points that fall inside it and a count field showing how many points fall inside it. Now, it's this count field that we actually want to get at. We could check the sum or the average or other statistics boxes here, and then the GIS will calculate values such as the sum of patients receiving chemo or the average diagnosis age for each polygon. But for the sake of time, we're just going to access just the count information. And we type an output name and click OK, and this is what the table output gives us. For every dissemination area, so every polygon, we now have a count of points in there. And of course, we can visualize this as well. And by accessing the layer properties of that new output polygon, we can then go to the Symbology tab and use quantities for graduated colors using the Count Value field. You can choose whatever color ramp you want. Again, you can click the Classify button and change your classification method, change the number of classes, and then click OK. And for the data that we work with, there's a lot of zero counts. When you have 333 records scattered across 5,357 dissemination areas for the province, it's going to get a lot of zero. So if we zoom in, here's the city of Edmonton, we can see we have higher values, darker shades of purple that indicate we have a higher count. Now, normally you would want to standardize or provide some normalization, a denominator to divide these counts to get ratios, or if you want to divide by the square kilometers of the administrative boundary, you could then get densities, and that can be done as long as those values are available in the attribute table. So that's something you can keep in mind for the future. Okay, and another fundamental analysis is proximity. So distance is something that a lot of people think of when they want to use a GIS, and so looking at the closest features. And in our research in Dr. Alvaro Osornio-Vargas's lab, we look at industrial emissions, air pollution, and the source of data that we use is the National Pollutant Release Inventory, which you can get from Environment Canada's website for free. So you can add that data, and then we can do a select by location. Now this, fundamental analysis is hidden in plain sight on the GIS software. It's right in the main menu. You go to the pull-down menu, selection, select by location, and then you get this wizard where you can select features from the locations that we're going to relate to the NPRI, or the industrial emitting facility layer, that are within a distance. And so you can apply a search distance and you can set the units. So we're going to look at just the CYP-C locations that are within a distance of 1 kilometer. And on the map, it highlights in bright blue where those locations are. And of course, if we zoom in, we can see more detail. And then when we open the attribute table, we see highlighted in the table all the different records that represent the patients within 1 kilometer of an industrial facility. And so we can see that there's 97 out of the 333 that were selected. And we can close the table when we're done. And it's also a good idea to click on this Clear Selected Features button at the top of the interface, because any selected features may affect future analyses. You may want to actually have these selected features, but it's always good practice just to clear them if you don't need them again. Another way to look at proximity measures involves a spatial join. So just like we did the point and polygon overlay, we can right-click on the point locations and do a joins and relates join. And we're going to be doing a spatial join, so join data from another layer based on spatial location. And the layer we want to join to is the MPRI facilities. And we'll choose the last option, where each point will be given all the attributes of the point layer being joined that is closest to it. And this is very important. It'll automatically calculate the distance for us for all those points. Specify an output name, click OK, and then you can open up the attribute table, and then this is what it looks like. So it gives us a new point file, which is an exact replica of the input locations point file, just like it did with the point and polygon overlay for the dissemination areas. Gives you new data when you do a spatial join. And here we have the CYP-C ID, the MPRI ID, and all the other attributes. I've turned most of them off just to simplify the display here. And here's the distance field that's been calculated. And for many records, you may want to get some statistics on it, and that's easy enough to do by right-clicking on that distance field, choosing statistics, and it gives you this nice little graphic that gives you a frequency or histogram. And then it tells you the minimum and maximum values and a few other basic descriptive statistics. And then, of course, you can also access the layer symbology and set it so that you have all those locations that are within 1,000 meters or 1 kilometer of an MPRI facility, shown as red, those that are 1 to 3 kilometers in yellow, and then those greater than 3 kilometers up to a maximum of 8 kilometers in the green. And so we're able to see visually information that we ask the map, that we ask the database table, and it helps us to explore the data and go on. So we're going to do a very quick demo here of what I've shown, and just need to get out of PowerPoint for a moment. I already have ArcGIS started up. For those of you who have used this before, the program takes a little while to start up. So I'm just going to show a couple of things in this demo because we don't have a lot of time. And I will try not to speak as much as I did through the slides, because you have that resource to look back on. You can see the screen captures, and that can help guide you to do your own future analysis. So as I mentioned before, this is what the ArcMap interface looks like. We have the main menu. We have a standard toolbar, and it's on this Add Data button that we can choose our base map. So when you have a blank screen like this, it's good to provide background information for context. And you do need an internet connection to be able to access, because these are free online services. And you can choose whichever base map that you'd like, and then click Add. And then this will take a few moments to come up. And then we can take these navigation tools, the zoom in, and we can figure out where we have Alberta. We can zoom into Edmonton and keep going. Here's the University of Alberta campus. And this particular map does not show the full Edmonton Clinic Health Academy building, but I can spy on Randy and friends in the building there somewhere if I had it. And the next thing we want to do is add our own data. So we would have to navigate to the directory where our data are stored. I'm going to choose the Alberta shapefile. And we can ignore this warning because it doesn't affect our actual data that we're going to be working with. It just affects the base map. And we're going to change the symbol. So just by clicking on the symbol patch, we can change to hollow and give it a thicker outline. And then we can see the base map below it. And then we'll right-click on Alberta, zoom to layer, and now we can see the whole province. And so this is not a good map projection. We're going to change that by, you can go to View and Data Frame Properties, and there is a Coordinate System tab where we can now choose the Alberta azimuthal equidistant, because this is what our Alberta boundary polygon is in. Click OK, and it's now going to reproject on the fly. And again, we could ignore this transformation warning. You can read more about this in online help. This, for our purposes today, it only affects the base map. So warning, if you have a slow internet connection, the base maps do tend to take a little bit of time. We'll right-click on Alberta again, zoom to layer. It gives us the optimal zoom in. Okay, so we're ready to add our points, and this will be under the Add Data button. And we find the Excel file of our simulated data. And if you hold the Control key, you can do multiple selections, and then click Add. And then the table of contents automatically flips to the list by source, and we can see the standalone tables. If you're in list by drawing order, you don't get to see those tables. It's a nicer, cleaner look to the table of contents, but the list by source shows us the folder where the data comes from as well as the standalone tables. So if you right-click and open the table, then you can see, okay, all our records have imported appropriately. You can also right-click on the other one. And so it is these two tables that we want to link to get the full description of the diagnosis group. Into the table that just has a code at the moment. So if we right-click on the data table, choose Joins and Relates Join, then we're going to join attributes from a table using that DX1 group, and the automatically finds the DX1 group spreadsheet and the same field name. Click OK, and then we also need to bring in our postal codes. Forgot to do that. So we'll go back into our Add Data, find the postal code file, click Add, and then these are all possible postal codes for the province of Alberta. You can see we're a very urbanized city, or very urbanized province. And now we can right-click on the data, go to Joins and Relates Join, and we're going to choose the postal code field, the postal code layer, and the postal code field. And click OK. And you can click Yes to create an index to make the performance a lot more optimal. Now when we right-click on the data table or spreadsheet and click Open, we have all that information in here. There's the longitude and latitude fields that we need to now view our data. As I mentioned before, to make this join permanent, we need to export this table, right-click on the table, and choose Data Export, and we'll make a standalone table, and we won't have to do those joins again. So we're going to save as a D-base type, and we're going to give it a name, joined. I recommend more descriptive names for your own work. I just want something short to type for today. And then you add the table, and now we can display our XY data using the longitude and latitude. The wizard automatically wants to choose the coordinate system of the data frame. Don't be fooled. We only have geographic data. It hasn't been projected. So click the Edit button, and you can go into Geographic. We're in the continent of North America, and NAD 1983. And this will be metadata that hopefully you get with any spatial data file if you need to do this. So click OK and OK, and we now have some new point locations. I'm going to check the box to turn off the postal codes, and we can now see the distribution of our 333 simulated cases. And this is an event layer. So to make this a true spatial data file, we need to right-click on it, choose Data, Export Data. And we can do two actions at once here. We're going to hard code the map projection. So because ArcGIS is able to reproject on the fly the geographic points onto the map projection of our custom azimuthal equidistant, it can then use that information to hard code it into the output points. Okay, so we'll give it locations shapefile and click OK. So remember, if you check the box that use the same coordinate system as the data frame, it will automatically have your data in that output projected coordinate system. So it looks identical to our joined events, just a slightly different color. And then I have just a couple of minutes to show you a few more things. We want to do our visualization of where we have more records spatially in the province. So if you right-click on locations, open the attribute table, we can then right-click on the postal code field to do our summary statistics or summarize. And it's going to automatically give us a count field. But as I mentioned before, you could choose statistics for other fields as well. And to save time, I'm going to grab the longitude and latitude. Save it as a D-base table. And it's pretty quick. Here's my table. I want to display it now. I'm going to choose the longitude and the latitude for XY. Edit that spatial reference. And I forgot to mention, you can always click the star to add your coordinate system to your favorites, and then you have a quick, handy way to grab that. And so this looks very similar to before, but now we can symbolize quantities as graduated symbols. We're going to choose that count of postal codes, and we'll just take the default for now. And we can see where we have larger numbers of records in different parts of the province. And the other analysis is the point and polygon overlay. We need to add our administrative boundaries. So these could be health regions. They could be other boundaries that you're interested in. And the join is the same thing. You right-click, joins and relates join, but we change it, instead of joining by attributes, to join data from another layer based on spatial location. And we'll choose the locations. And we want this count field showing how many points fall inside it, so we keep that box checked. Type the output name. And so it looks exactly the same as before, just a different color. But we can symbolize this, showing quantities as graduated colors. This is known as a choropleth map, and we can use that count field. And you can choose whatever color ramp you want, and you can change the number of breaks. And if you click this classify button, this is where you can change that classification method. So just like you have in your statistics software, you can change the method that you use to bin or aggregate your data, and then the same number of classes. It also gives you a quick, handy look at the descriptive statistics for it as well. You can even manually go in and change your break values if you'd like. So click OK. And we now have representation of 0 to 6, which is our total number of, or max number of records for any polygon. And if you zoom in, you can see the distribution where you have more records. Okay, and we have time to go through one of the proximity analyses. And so you've seen how the spatial join works here. So I'm going to do the selection. We'll zoom back out. And we can turn some of these layers off. We're going to add in our MPRI facilities. And this data I've subset to be within 30 kilometers of the provincial boundary. This data set is Canada-wide. And the select by location is where we can choose to select features from the location. The source layer is the industrial facilities. And the spatial selection method, there are a lot. So you can go through each of these and try them out and see if it's going to answer a research question that you have. Sometimes it might be the backwards or opposite that you want, so then you can just switch your selection later. This one we want to have within a distance of the source layer feature, and we're going to change the units to kilometers and the units, and then you can apply and then close, or if you just click OK, it will automatically dismiss the window and highlight where we have locations that are within 1 kilometer of the industrial facilities. So we can see that not all of the locations in Edmonton are within 1 kilometer. We can turn on those MPRI facilities and see where they are. All those red dots are MPRI facilities. Okay, and as I mentioned before, be sure to set your map document properties. Check this box, store relative path names to data sources, and then when you go to save your map document, you shouldn't get broken data links if you move that whole folder of data to another computer. So here's the help. It's also online. The links that I have on the PowerPoint go to the online. So here's some resources for anybody who wants to learn more if you're so inclined. There's an excellent textbook, GIS and Public Health by Cromley and McLafferty. If you're at a university of access, you could probably get it for free, and the University of Alberta actually has it as a digital ebook, so the link is here. There's a GIS tutorial for health by Kurland and Gore, which is really excellent. You can go through, it has data you can download and learn all kinds of analyses for health and medical research in GIS, and there's also a free ebook from the University of Alberta Library. The Center for Disease Control and Prevention in the U.S. has some great online training in GIS and public health. And the makers of the ArcGIS software have wonderful webinars and online courses and videos and things like that. If you're associated with an academic institution that has a site license for ArcGIS, you will also have access to unlimited free training. And for those of you who like to use SAS, there is a bridge for Esri that helps the two softwares to communicate a lot more. So in review, we've learned that GIS is a system of 5 important components, that when you get started, you want to have context and the appropriate map projection or coordinate system. When you're geolocating your tabular data, you have a few steps to go through. When it comes to doing some analyses, we looked at some fundamental ones, looking at statistics and visualizing that, some overlay and proximity analyses, so where we have higher, lower counts, distances to other geographic features, and I've given you some hopefully useful learning resources. Okay, so that concludes the presentation part of today. I hope you've gained some useful knowledge for your own research. So thanks for attending, and thanks to my PhD co-supervisor, I have
unmuted,
and my statistically savvy colleague Jesus, who's been working a lot more with the CYP-C data on the statistical side of things, as well as the Domino project team, the data mining and neonatal outcomes. We conduct research from the Children's Health and Environment perspective, and many of the data files we share between the different projects in Alvaro's lab. And thanks to Randy for this opportunity.
Great. Well, thank you very much, Charlene. I think it was a tremendous overview, and I think people can really see the power of what's available to them by switching and using a geographic information system. So there's still a few minutes left, so I'll open the floor up to questions for anyone that has any questions for Charlene. Maybe I'll start with a question then, Charlene. So the data, when you linked the postal code information, you had a separate data file that basically had already geolocated all of the postal codes.
Yes.
Is that correct?
Yes.
And that is from ArcGIS, or was that from another source?
That's from government. There's the postal code conversion file that we'll be learning about in a future webinar. Mm-hmm. And there's also enhanced versions of that.
Okay.
From DMTI Spatial that takes the postal code conversion file and does some population-weighted centroids and picks out the unique postal codes, because when you look, if you were to look at the country and where Canada Post delivers, they have what's called local delivery units, and you can have the same postal code for multiple areas, especially in the rural residential areas. And so then you need to grab the single postal code, because you can't have multiple postal codes representing one record.
Yeah. So
this is an issue in the rural. And I'm not going to talk too much about this, because that will probably be discussed in the future webinar. The postal code conversion file is the one that most researchers use because it already has the data linkage to census geography. But both the files come as tables, and then you can use the display XY and create your own spatial shapefile or feature class, which I had already prepared for this webinar because it would take a lot longer if I had to do everything from scratch.
No, that's great. I just wanted everyone, I wanted to understand how you got from what I thought was the geocode, the PCCF file, to the file that you actually used. So that's great.
Yeah. Well, the exact same process that we used with the joined table of CYP-C data. Display the XY is the exact same way you can take the actual postal code file and make it spatial.
Great. Any other questions?
I've got a question.
Okay.
About the distance, for the distance calculations, are these, I'm just thinking in terms of here in Ontario where we have these the big lakes and we've got communities on opposing shores.
Right.
These straight line distances, or?
Yeah, the examples that we did today were straight line distances, which are better for urban areas that don't have lakes getting in the way.
Right.
You may want to get into more sophisticated analyses where you're using network analysts, and you would have a road layer, and then you would be calculating actual distances that people would drive for transportation purposes. However, you can get into raster analysis using raster data sets, and you can use masks to basically say, don't calculate the distance where I have these big water bodies, but give me the shortest path that goes along land.
Okay.
So it wouldn't follow the roads, but if you wanted kind of as
make it a bit more realistic.
As the deer would run across the landscape instead of as the crow flies, right?
Right. Okay, thank you.
You're welcome.
I think we have time maybe for one other question, if there's any out there. Okay, well, hearing none, it's my pleasure, Charlene, to thank you for coming and presenting to us. I think we all look forward to the analysis, the final analysis output for the CYP-C data that you have, and we thank you for coming and sharing with us some of your knowledge around the geographic information systems and how to use them. So thank you very much. Yeah,
you're welcome. Yeah, it was a little bit difficult trying to fit everything into 1 hour. So I initially was going to have some cartography and mapping and that information, but it would have been way too long. And then there's a whole bunch of geoprocessing, spatial statistics, and other tools available in the GIS software, but each of those could be a webinar easy.
I think that's one of the things that your talk highlighted for me was how little I know about these things. So, which is great. I mean, I think it takes specialists like yourselves to really help us understand these things. So that's fantastic. And I think everyone has your contact information too. If people are looking for collaboration, I would imagine you might be open to that. Yeah, my email address is on the front slide. And I'm just going to draw everyone's attention to slide number 31 that has all the resources. There's way more than this, but I was just selective and didn't want to overwhelm you with too much. That's great. All right, well, thank you again. And it's, I guess, so this will close this webinar session. Just to say that our next webinar will actually be on September 22nd, and then we'll actually be talking about census geography. So we won't necessarily be talking about it in a geographic information sense, but just using the data that you can actually garner in a flat table format, more or less like the data that we're used to using, and how you might link that to some census geography, and then ultimately onto some other outcomes like socioeconomics data. So that'll be on September 22nd. And then I also wanted to highlight that actually we are planning a champion